Hi guys, this is the EdExcel AS Level Further Maths paper from the June 2019 series, and in this video we'll be taking a look at the Further Pure Mathematics 1 FP1 module. Okay, so in terms of the examiner's report for this paper was accessible across the ability range, and most candidates found plenty of opportunities to demonstrate the knowledge. There was some testing questions involving the vector product and coordinate geometry that allowed this paper to discriminate well between higher grades. In a significant number of cases, candidate solutions were difficult to read. This was a result of either poor handwriting, incoherent working, or disorganized presentation. For question 1, for part A, we have to write down the t formula for sin x. That's quite straightforward. Sin x, that's equal to t over 1 plus t squared. For part B, we have to use our answers to part A to find the exact value of sin x when tan of x upon 2 equals root 2. And then we have to show that cos x equals 1 minus t squared over 1 plus t squared. So we've got t equals tan of x upon 2 equaling root 2. We wish to find the exact value of sin x, and all we have to do over here is simply substitute in this value of t into our formula for sin x. So sin x, that's equal to 2t, so we have 2 root 2 over 1 plus t squared, so we have 1 plus root 2 squared, so we have 2 root 2 over 1 plus 2. It turns out we get 2 root 2 over 3. And then, using our answer to part A, we wish to show that cos x is equal to 1 minus t squared over 1 plus t squared. First of all, you should be familiar with the result that cos x is equal to sin x over tan x. Now, sin x, we already know what that is. That's 2t over 1 plus t squared, and we divide this by tan x. Now tan x, that's the same as 2t over 1 minus t squared. You'll notice the 2 t's cancel on the top and the bottom. We therefore see cos x is equal to 1 minus t squared over 1 plus t squared. Okay? Now for part C, we have to use the t formula to solve for theta being in between 0 and 360 degrees. 7 sine theta plus 9 cos theta plus 3 equals 0, giving it answers to 1 decimal place. Okay, so for part C, we have 7 sine theta plus 9 cos theta plus 3 equals 0. We know what sine theta and cos theta are in terms of t. So we have 7 lots of 2t over 1 plus t squared plus 9 lots of 1 minus t squared over 1 plus t squared plus 3. This is equal to 0. And if we multiply through by 1 plus t squared, you can hopefully see that we have 7 lots of 2t plus 9 lots of 1 minus t squared plus 3 lots of 1 plus t squared, all this is equal to 0. And if we expand and simplify, we have 14t plus 9 minus 9t squared plus 3 plus 3t squared equals 0. And if we collect like terms, we have minus 6t squared plus 14t plus 12 equals 0. And now if we multiply both sides by minus 1, we have 6t squared minus 14t minus 12 equals 0. Now, with this quadratic equation, there are various different ways to solve this. You can complete the square, you can use the quadratic formula, you can factorize. Factorizing this, we have t minus 3 lots of 3t plus 2 equals 0. And therefore, we see that t is either equal to 3 or minus 2/3. And therefore, we can see that tan of theta upon 2 is either equal to 3 or minus 2/3. Okay? And we wish to find the values of theta in between 0 and 360 degrees. So, theta upon 2, that's equal to, and if we grab our calculator, make sure that we're in degrees, the inverse tangent of 3, that would be 71.56, etc. And the inverse tan of minus 2/3, that's minus 33.69, etc. And when we come to multiply that value by 2, we'd end up with a value that's smaller than 0. So therefore we have to add on 180 degrees. So theta upon 2 is also equal to 146.30, etc. And therefore, if we multiply both sides by 2, we want to give our answers to one decimal place. We can therefore see in conclusion, theta is equal to 143.1 degrees and also 292.6 degrees. Okay? Question 1, that was accessible to most students, but a certain number of students struggled with this part of the question. For part A, a lot of people were successfully able to recall the formula for sin x in terms of t. For the first part of part B, most candidates substituted their value of their value of t equals root 2 into sin x, and they got the correct answer 2 root 2 over 3, which is well done. For the next part, however, that proved to be a bit more difficult. Remember, the question said use the answer to part A, so we had to use what we had over here to show we get this result here. And there's various things that are mentioned in the examiner's report regarding this part. There were different attempts. There were some attempts that contained incorrect algebra or were incomplete because of errors in forming and factorizing a quadratic expression, or an error in using a numerator of t squared minus 1. A few attempts applied tan x equals sin x over cos x with tan x equaling 2t over 1 minus t squared and sin x equaling 2t over 1 plus t squared. And those who did that were successful in showing that you get this result. And that's the method I took as well. There were candidates who used the formula cos x equals cos squared of x upon 2 minus sin squared of x upon 2 to a right angle triangle with the angle x over 2 edges 1 and t, and the square root of 1 plus t squared did not receive any credit. I did not use the answer in part A, so that was quite important. Make sure that you use your answer in part A. For part C, where we had to solve this equation, that was done pretty well by a lot of people. A lot of people did what I did over here, used the substitutions for sine and cosine, and they arrived at a correct quadratic. Now the issue was in actually finding the angles. This is nothing more difficult than what you'd find out in your regular A-level maths, but some people halved rather than double. Remember, we've got theta over 2, so we have to multiply both sides by 2, and you also had to bear in mind the range of values you want. Okay. For question 2, a student was set the following problem. So their problem was that they had to use algebra to find the set of values of x for which x over x minus 24 is greater than 1 over x plus 11, and the student's attempt at a solution is written below, and there are errors in the student's solution. We have to identify the error made in line 3 and in line 7. Well, if you take a look at their solution, they've multiplied both sides by, if I write this down, they've multiplied both sides by x minus 24 all squared lots of x plus 11 squared. So let's just write the same thing on the other side. So we have x minus 24 all squared lots of x plus 11 all squared, and hopefully you can see that this cancels with this and this cancels with this to give this line over here. Then they've taken everything over to one side, and then they've attempted to factorize. They've noticed that in common they have an x minus 24 lots of an x plus 11, and then inside this big bracket they have x minus x plus 11, which gives this term, and then they have over here minus x minus 24. Well, this is incorrect because the x minus 24 should be in a bracket. And in terms of line 7, once they've solved the inequality, they've, as you can probably tell by looking at this graph over here, they found the regions where the inequality is less than 0, and we're looking at the regions where the inequality is greater than 0. So we've got those two statements written down over here. X lots of x plus 11 minus x minus 24 should be x lots of x plus 11 minus, and then in brackets, x minus 24. And for the next part, they have found the regions where the inequality is less than 0. And now for part B, we have to find a correct solution to this problem. Okay. So for part B, we wish to solve the inequality x over x minus 24 being greater than 1 over x plus 11. There's various different ways of doing this. You can either correct the mistake in line 3 and then continue, or you can do the way that I will show right now, and that is to take everything over on one side first. So we have x over x minus 24 minus 1 over x plus 11 being greater than 0, and if we combine these fractions, we have x lots of x plus 11. Okay, so let's write this down. We have x lots of x plus 11 minus 1 lots of x minus 24 over x minus 24 lots of x plus 11 being greater than 0. Okay, and if we expand and simplify all this on the top, we have x squared plus 11x minus x minus 24. On the bottom, we've still got this x minus 24 lots of x plus 11. And this is greater than 0. And if we simplify on the top, we have x squared plus 10x minus 24. Sorry, plus 24. And that's because we have minus 1 times by minus 24. And on the bottom, we've got x minus 24 lots of x plus 11 being greater than 0. Okay? And on the top, we can factorize that. So we have x plus 6 lots of x plus 4. On the bottom, we've got x minus 24 lots of x plus 11, and this is greater than 0. And at this point, I think it would be a good idea to sketch this rational function. Having drawn the graph, we have an asymptote at minus 11 and 24. That's from the bottom. And therefore, we end up with this sort of graph over here. And we're looking at where this graph is greater than 0, anything above the x-axis. And we see that the graph is greater than 0 when x is less than minus 11, in between minus 6 and minus 4, and also when x is greater than 24. So, in conclusion, we're looking for the set of real values where x is greater than less than minus 11, or x satisfying a set of real numbers being in between minus 6 and minus 4, or x satisfying a set of real numbers where x is greater than 24. Okay, so that's our solution. Question 2 was regarding inequalities. This was well answered, but a lot of people struggled to give the correct answer in part A, and part A required some sort of an explanation. For the first part, a lot of people did recognise the mistake that this x minus 24 should all be in a bracket. For the next part, on line 7, there were a lot of candidates who realised that this person had solved the inequality the wrong way around. But this was inadequately explained in some candidates' work. For example, some said solve for x being less than 0, which is incorrect. Some candidates said that the set notation was wrong. For example, it should be and not or. Okay, and now when we came to find the correct solution, most candidates achieved the correct critical values and then went on to choose the appropriate regions. A small number failed to use set notation. A few candidates made the same sign error as the student in question 2A and thought that all they had to do in part B was to correct the student's line that this part of the question's worth. That doesn't make sense to do that. For question number 3, Julie decides to start a business breeding rabbits to sell as pets. Initially, she buys 20 rabbits. After 2 years, the number of rabbits R is modelled by the differential equation dr over dt equals 2r plus 4 sine t, where t is greater than 0. Julie needs to have at least 40 rabbits before she can start to sell them, and we have to use 2 iterations of the approximation formula. Dy over dxn is approximately y n plus 1 minus yn over h to find out if, according to the model, Julie will be able to start selling rabbits after 4 months. So the first thing you need to recognise is, initially she buys 20 rabbits. So that tells us that t0 is equal to 0, and initially she buys 20 rabbits, So R0, that's equal to 20. And we're looking to find out how many rabbits there are after 2 iterations. Now T2 after 2 iterations, that's 4 months, and you have to be a bit careful over here. You'll notice in the question we were told it says after 2 years, so 4 months, that's the same as a third of a year. Okay, and to work that out, 4 months divided by 12 months, that's a third. So we see that T2 is equal to 1/3, and we're finding out what R2 is. And we see that we require two iterations to go from 0 to 1/3, and therefore H is equal to 1/6. Okay, and we've got this differential equation stated here, dr over dt equals 2r plus 4 sine t, and we've also got this approximation formula, which if we write in terms of r and t, we have dr over dt n being approximately r of n plus 1 minus r of n over h, which if we rearrange this, we therefore see that r n plus 1 is approximately rn plus h lots of dr over dt n, where n is equal to 0, 1, 2, etc. Okay, so with this we can actually start to work out our first iteration, but before we do that we need to work out what dr over dt 0 is, and we can do that using this differential equation given. So far we've been given that T0, R0, that's equal to 0, 20, and dr over dt 0, that's equal to, if we substitute into here, we have 2 lots of 20 plus 4 sine t, so we have 4 lots of sine of 0. Make sure that we work in radians. Turns out we get 40. And with this we can find out what R1 is using this formula here. R1, that's equal to R0 plus H lots of dr over dt 0. So we have R0, which is 20, plus H, which we know to be 1/6, lots of dr over dt 0, which we just found to be 40. If we work this out, it turns out we get 80 over 3. Okay, and now that we know what R1 is, we can therefore conclude that T1 R1 is equal to 1/6 80 over 3. And now we can use this information to find out what dr over dt 1 is. So what we have over here then is 2 lots of 80 over 3. Okay, so we have 2 lots of 80 over 3 plus h, which is plus 4 lots of sine t, so we know that t is equal to 1/6. And if we work this out using our calculator, so first of all make sure that we're in radians. We have 2 lots of 80 over 3 plus 4 times by the sine of 1/6. It turns out we get 53.99, etc. I recommend storing this value into your calculator. The reason for that is we need to use this value in our next iteration. So we now need to find out what R2 is. R2, that's approximately R1 plus H lots of dr over dt1. So we have R1 80 over 3 plus H, which is 1/6, lots of dr over dt1. So we have 53.99, etc. And if we work this out, so if we divide this by 6 and then add on 80 over 3, it turns out we get 35.66. Okay? And we see that this value over here is less than 40. Remember, we were told that she needs to have at least 40 rabbits before she can start to sell them. And therefore, we see that this value over here, which we've just found, this is less than 40, so either way you look at it, 35 rabbits or 36 rabbits, it's still less than 40. And because of that, we can therefore conclude that Julie will not be able to start to sell her rabbits. So we have Julie will not be able to start to sell her rabbits. Okay. Okay, so that's our final answer. Question 3 was concerning using an approximation to solve a differential equation. Most candidates applied the 2 iterations of the correct formula very well, which is good. With R not equaling 20. There were common errors, and one of the common errors was finding out the value of H. Remember, I think the fact that it says T is in years and then you've got 4 months, I think that's what threw a lot of people off, and because of that they gave the incorrect value of H. A couple of candidates were working in degrees, which is incorrect. You have to work in radians because we're solving a differential equation. And nearly all candidates gave a correct conclusion in the context of their estimated value of R2, which is good. Question number 4. Figure 1 shows a sketch of a solid doorstep made of wood. The doorstep is modelled as a tetrahedron relative to a fixed origin O. The vertices of the tetrahedron are A with coordinates 2, 1, 4. Let's just add these to the diagram. A has coordinates 2, 1, 4. B has coordinates 6, 1, 2. C has coordinates 4, 10, 3, and D has coordinates 5, 8, D. D over here is a positive constant and the units are in centimetres. I think it's a good idea to highlight that. D is a positive constant and the units are in centimetres. For part A, we have to find the area of the triangle ABC. That's actually quite easy. First of all, the area of the triangle ABC, that's equal to 1/2 times the magnitude of the product of AB times AC. So we need to actually work out what the vectors AB and AC are. So the vector AB, that's equal to 6 take 2, which is 4, so we have 4i. 1 take away 1, which is 0, so we have 0j. 2 take away 4, that's minus 2, so we have minus 2k. AC, that's equal to 4 take away 2, which is 2, so we have 2i. 10 take away 1, which is 9, so we have 9j. And then 3 take away 4, that's minus 1, so we have minus k. And if you actually read ahead, at some point we'd have to use the volume, so we might as well also work out AD as well whilst we're at it. So AD, that's equal to 5 take away 2, which is 3i, 8 take away 1, which is 7, so we have 7j, and then we have d take away 4k. Okay, so at some point we'll be using all of these. So for part A, when we come to work out the area is equal to 1/2 times by the magnitude of AB multiplied by AC. Okay, so we have 1/2 times by the magnitude of 4i minus 2k multiplied by 2i plus 9j minus k. Okay, so we have 1/2 times by the magnitude of these two vectors multiplied together, so we can use our calculator to work this out. So we have 4, 0, minus 2 for vector A. Vector B will define to be 2i plus 9j minus k. And if we multiply those together, so we have 3 vector A times by vector B, it turns out we get 18i plus 36j. Okay, so we have 1/2 times by the square root of 18 squared plus 36 squared. So if we work this out, we want to find the absolute value of what we've just worked out. And if I multiply this by 1/2, it turns out we get 20.124, etc. So therefore we end up with 20.1 centimeters squared to 1 decimal place. Okay, so that's that done. And now, given that the volume of the doorstep is 21 centimeters cubed, so that's actually quite important, the volume of the doorstep is 21 centimeters cubed, we have to find the value of the constant d. So first of all, you have to recognize that we have a tetrahedron that we need to work out the volume for. So for part B, the volume of the tetrahedron, that's equal to 1/6 times by the magnitude of AD dot product with AB times by AC. And we've already worked out what AD is. Remember, that was 3i plus 7j plus d minus 4k. And we need to dot product this with AB times AC. AB times AC, if I grab a different colour highlighter, we see that AB times by AC is 18i plus 36j. Okay, so we have this dot product with 18i plus 36k. Okay, so if we work this out, we have 1/6 lots of the magnitude of, well, 3 times by 18, that's 54. 7j times by 0j, that's 0. And then we have d minus 4 lots of 36. So we have 36 lots of d minus 4. Okay, so we have 1/6 lots of the magnitude of 54 plus 36d minus 144. And we know that this is equal to 21. Okay, we were told in the question that the volume is 21. Okay, so we have 1/6 lots of the magnitude of this bit over here simplified, so we have 36d minus 90 equals 21. And if we solve this equation, we have, sorry, here we have 36d. We have 36d minus 90 modded equals 6 times by 21, which is 126. So we have plus minus 36d minus 90 equals 126. If we solve for the positive one, we have 36d minus 90 equals 126, and if we solve for the negative one, we have 90 minus 36d equals 126. Here we see that d is equal to 6, and here we see that d is equal to minus 1. And since d is a positive constant, we can conclude d is equal to 6. Question 4 was concerning vectors. This was quite accessible, but then a lot of people struggled with part B of the question. For part A, a lot of people found the area of the triangle correctly. Some candidates found the correct answer by applying the vector cross product between the other two edges of the triangle ABC, so it doesn't make a difference what edge you start off at, as long as you have the direction pointing outwards. So common errors included the cross product calculations finding AB times AC even after previously stating the correct formula a half times by the magnitude of AB times AC. So you just have to remember this half because it's a triangle. Or misconstructing the area times OB. So you have to use AB times AC, not OA times by OB. For part B, that was more challenging than thought. A lot of candidates used a complete method of this formula over here to find D, but instead of using the 1/6, some used a third, some used a half, which was incorrect. But those that did use this bit over here and got onto this bit usually achieved the correct formula after getting to this stage. But there were some candidates who, once they got here, they made some mistakes, such as writing 54 squared plus 3d minus 144 squared, which is incorrect. Remember, this is just a constant value, it's not a vector, so you don't have to square root like that. Okay. Another common error was to simplify 3d minus 90 modded to give 3d plus 90, which is incorrect because you don't know the value of d yet. Or they did 36d all squared plus 90 all squared square rooted, which is incorrect. Remember, it's just modded, so you don't need to do that. Question number 5. We have figure 2 over here, which shows a sketch of part of the rectangular hyperbola h with equation xy equals c squared, where x is greater than 0 and c is a positive constant. Now, the point P with coordinates ct and c over t lies on h. The line L is a tangent to h at the point P. The line L crosses the x-axis at the point A and crosses the y-axis at the point B. The region R, shown shaded in figure 2, is bounded by the x-axis, the y-axis and the line L, and given that the length OB is twice the length of OA, where O is the origin, and that the area of R is 32, we have to find the exact coordinates of the point P. Well, first of all, we can rearrange this equation here and then differentiate that. The reason we want to differentiate is at the point P, the line L is a tangent to the curve. So we have the equation for H, that would be y equals c squared over x. Okay? And therefore dy over dx, okay, dy over dx, that's equal to minus c squared over x squared. Okay? And we can find out the value of the tangent by substituting in the coordinates of P into dy over dx. So considering this point P with coordinates ct and c over t, we have dy over dx, which is equal to minus c squared over x squared, and notice x over here is ct, so we have ct squared, so we have minus c squared over c squared t squared, so we have minus 1 over t squared. Okay, so therefore the gradient of the tangent is equal to minus 1 over, we have minus 1 over t squared. Okay, and with this we can find out the equation of the line, and from that we can find out the coordinates of A and B. That will be useful for us to find out the value of C and T, and we also know that OB is twice OA. So in terms of the line L that's given by y minus y1, so we have y minus c over t. Again, we're considering this point P, so perhaps if we move this under here, so we have y minus c over t equals the gradient minus 1 over t squared, lots of x minus x1, so we have x minus ct. So if we tidy all this up, we have y equals, well here we have minus 1 over t squared x, and then we have minus 1 over t squared multiplied by minus c over t, which is positive c over t, and then if we add this to the other side, it turns out we get 2c over t. Okay, so we have 2c over t. There's nothing complicated in what I've done over here. Now, that's our equation for L. Okay? And therefore, or perhaps if we make this a bit more clearer, that L is given by this, we can now find out the coordinates of A and B. Now, when x is equal to 0, so when x is equal to 0, we can find out what y is. Y will equal 2c over t, and therefore the coordinates of B would be 0 and 2c over t. Okay? So we have 2c over t. Okay, so when y is equal to 0, if we work this out, we have 0 equals minus 1 over t squared, lots of x, plus 2c over t. So we have 1 over t squared x equaling 2c over t, and if I multiply through by t squared, we can therefore see that x is equal to 2 2tc. Okay, and therefore the coordinates of A would be 2tc 0. Okay, now therefore that tells us, well, first of all let's add this to the diagram. We have the coordinates of A 2tc 0, the coordinates of B, which were 0 and 2c over t. We can therefore see that the length of OB over here, OB is equal to 2t over c, and OA over here, that's equal to 2tc. Okay, and we also know from the question that the length of OB is twice the length of OA. So with that information, we can therefore say that 2c over t is equal to twice 2tc. And the reason for that is what we said before. Okay, and therefore with this we can find out the value of t. So we have, if I multiply through by t, well, first of all we see that 2c is equal to 4t squared c, and therefore t is equal to 1 over root 2. Now it's quite important that you take the positive solution only. Well, first of all, the c's cancel on both sides, so we have t squared equals a half, and therefore t equals 1 over root 2. It's important that you take the positive solution, because if you look over here for p is in this first quadrant, so therefore t must be positive, so t is equal to 1 over root 2. And we also know from the question that the area of R is 32 units squared. So with that piece of information, you'll notice R, that's a triangle. If you look over here, that's just a triangle. So with that, we have 1/2 times by 2c over t lots of 2tc equals 32. So this comes from the fact that the area of R is 32. So with this you can hopefully see that we have a half times by 4, which is 2, and if I divide that by 32 we end up with 16. The t's cancel here, so let's just show that the t's cancel over here, and therefore we have c squared equals 16, and therefore c is equal to 4. Remember, we take the positive solution because we're looking in this first quadrant here. And knowing the value of t and c, we can therefore conclude that the x coordinate of p is equal to, if we go back to the question, the x coordinate of p is equal to ct. So we have ct, so we have 4 times by 1 over root 2, which is 2 root 2, and the y coordinate of p, that's equal to c over t. So we have c, which is 4, over t, which is 1 over root 2. It turns out we get 4 root 2. And therefore, from here we can conclude quite easily that the coordinates of p in exact form, we have 2 root 2 and 4 root 2. Okay, so let's just add this to the diagram. We have 2 root 2 and 4 root 2. Okay, So that is the end of the questions. Question 5 was concerning rectangular hyperbolas. Its unstructured nature of the unstructured nature of the question proved this question to be quite difficult, and a lot of people did not know how to formulate their answer, a clear strategy. There were a huge range of methods were viable, most of which were seen, although way one, as described in the mark scheme, which is I think the way I did it, was the one that gave the correct, that was the most successful answer. A significant number of candidates progressed as far as finding an equation for L, so they came to this stage pretty well. And then with that, they could find out where L cuts the x-axis and the y-axis, and errors seen for those who had made further progress included OA equaling to OB, and remember it was the other way around. Applying base times by half when finding the area of the triangle OAB, so you have to multiply by a half. There was another one of using OA to OB equals 1 to 3 as a ratio, believing that t squared equals a half leads to t equaling a quarter. It doesn't. If you want to put that into your calculator, you'd come out with t equaling 1 over root 2, or simplifying 1 half lots of x lots of 2x to give either a half x squared, 2x squared, or 2x. I don't know what that's on about. In a whole, it was a significant number of well presented correct solutions.